And today is the sixth and final training session for component methodology developments on the ICS platform. And we will be looking at some of these topics. The first is just to provide a summary from the last sessions we've had. We'll then talk about component methodology design and development, specifically looking at monitoring component methodologies. We'll then look at the example project that we've been developing over this series and focusing on that monitoring component. We'll then go through a process from the simplest model, adding a little bit more complexity in each step. During this process, we may switch between the example project because this creates a context for using component methodologies and then the details of the component methodologies themselves. And so the example projects are an important part of developing your component methodologies. And then finally, we'll talk about the different documents that we use for summarizing and reporting methodologies and projects. So to summarize what a component methodology is, it provides a template for the development of emission reduction projects. The methodologies define the information that's required while you're developing a project. And it also defines the calculation procedures and methodologies used within those projects. An overall view is that one would start off with the physics of the emission reduction. These would be described within your component methodology. That then is represented in terms of the maths for the calculations that one would do to reduce your emission reductions. And then that gets converted to some code that a computer is able to solve or a given set of data from your project. This process is there to ensure that the emission reductions are credible and that they can be verified by an auditor. Just to give a summary of the previous project that we were looking at. This project here is the one that we've been developing over the series. So I'm looking at the projects page. I've then put a filter on to look at the specific example project that we've been developing. And over here, I'm going to view the details of the project. So through the series of this training, we've been going through the process of developing these different component methodologies. The first one provides for collecting information related to project details, such as things like the location, who the owners of the project are, what is the purpose and technologies used within the project type. The second component methodology we looked at was defining a baseline. And this is a baseline calculation to determine a grid emission factor. The third component methodology that we looked at is to prove additionality for a project. And this looked at information related to investments within the project. The fourth component methodology here is the monitoring and evaluation component methodology. This is one that we'll focus on today. Um, with the component methodology design and development, we define some important requirements for monitoring component methodologies. First of all, we need a description of the monitoring system. Quite often with the carbon credit projects, there will be diagrams representing the different instrumentation or equipment used within a project. The diagram we're showing here is related to a landfill gas project. We also need information about the monitoring procedures. This may include the frequency of data collection. What instrument will those procedures use? And it would also include things like the calibration of the instruments that you're using. Linked to the instruments and the measurements are specific variables or parameters that we use to log data that's used in the calculation. There may be other information, like if there's leakage from the project, and the monitoring methodology can then define calculations for that. Related to the instruments is that each instrument may have a certain level of uncertainty or accuracy, and these then are used in terms of the calibration of the instruments to ensure that the measurements that you're taking are accurate. So now we'll look at the component methodology for monitoring for that example project that we set up, and we'll look at the details related to that. So now I've switched back to the example project report. And I find this is an easy way to access the different component methodologies that we're looking at. There could be other ways. You could go to methodologies, my methodologies. If you then know the details, I remember the code number that we were using, it's 85. This is then another way to access that component methodology. So we've pre-populated this methodology for monitoring the generation of electricity from solar PV. Here we're providing some of the background information, like what is the methodology compatible with. There were the baseline and the additionality methodologies that we developed in the previous sessions. Here we define what type of component methodology. It's the monitoring one. It's used for calculation of emission reductions. Because it's solar PV, it's related to energy industry, and we haven't submitted anything for approval. Once again, with the component methodologies, one would set up a list of questions related to the information you need to collect from the project developer. With this one, I'm focusing on the calculation procedure. We will get to a more complex one where we'll look at more details in terms of the types of questions we need for a monitoring methodology. But it would generally be what's your monitoring plan and a description of the equipment. In terms of this monitoring methodology, we only define two sets. The first one is a default set, and this is used to track the monitoring periods. And its main use is to aggregate the information for a monitoring report, which reports on the emission reductions over a monitoring period. The second set we define is a list of months. This is because we propose for this methodology that data will be collected once a month. So we define the set called months. In terms of the parameters, there's certain parameters that one always needs, such as the project emissions and the emission reductions. And then we define things like the emission reductions for a monitoring period, which is an aggregate of the emission reductions for each month in that monitoring period. And we also define the start and end of the monitoring period. And here we also got the aggregate of the project emissions for the monitoring period. So this is the simplest example type project we can set up. Just in terms of the user interface, you will have preferences as you go along. I find it quite useful to sort the table here when looking at these, because the different parameters will be relevant to the development procedure. So it's quite often that one would first define your input parameters and then define your output variables, because all of these output variables may depend on some calculation related to the input parameters that you have. So in this case, we've only got these 3 inputs, and then we calculate these 3 outputs. So in terms of the equations that we need, it's helpful looking at the equations in the context of what we've defined for the aggregations that we need. And you'll see here that when we look at the equations, such as the project emissions, here we're doing a calculation that's calculating the project emissions for the monitoring period. And this is looking at the sum of the project emissions for each month. So this equation here is looping through the months. It's adding up the project emissions from each month into the for the monitoring period. The emission reductions, in concept, the way this project is working is that your emission reductions is a result of substituting grid electricity with renewable energy. And so here we can see we've got the electricity consumption from that's being consumed from the project. We multiply that by the grid emission factor. The divide by 1,000 is to make sure we use the correct units. The units are an important thing to look at when defining your parameters. And then we are subtracting the project emissions. In this case, the project emissions, because it's a PV project, there are no emissions from the project, so this value will essentially be 0 for all the months. This last equation here, what it's doing is it's aggregating the emission reductions for each month over the whole monitoring period. So this is the simplest type of project we can get. In reality, we're only measuring one parameter, and that's the electricity consumption, or the electricity that gets consumed from the project. Okay. Once we have our component methodology set up, it is then possible to go and look at a report that summarizes this. But essentially, this summarizes the methodology online, and then I'll show a little bit later how one gets a PDF report that summarizes the methodology. Okay, in the next step, what I would like to show okay, we've discussed that. In the next step, I'd like to show an additional bit of complexity within the calculations that can be possible. The methodologies, when you set them up, you define how complex they are. And that complexity will depend on the trade-off between how general you want that methodology to be so that other people can use it, or how specific you want that project to be so that you can simplify the calculation procedure. The idea may be to strike a balance between those, because you can get royalties from your component methodology, but then you wouldn't want to build a component methodology that's so complex that nobody understands it, or it's difficult to collect data for it. Okay, so here I've just got a different browser window open. And this is then going to look at another example project that we've set up. It's also a PV project. You will note that here I'm using app.inclusivecarbon.org. This is actually the live platform. And there are some component methodologies that we've set up on the live platform. And users of the platform can go there and provide comments where a project has been submitted for public comment. But that's just a sideline. So in this project here, it's very similar to the one that we've been developing, but it's more comprehensive in the sense that here we want to actually demonstrate more comprehensive component methodologies. So again, you'll see we have to have a project details, component methodology. We need a baseline, component methodology, additionality, and then monitoring and evaluation. Within this example project, we have also included a tag. We can go and look at some of the details related to these. I'm specifically interested in this monitoring and evaluation component methodology. Because this is a methodology that we have online, it is a little bit more detailed. You can see here from the descriptions and the questions. So the project details here are then asking information about the monitoring procedures, the environmental and social impacts, and if there are any deviations from the monitoring plan. Then we also have a section here looking at the data quality. How does one do the data measurements? Is there a calibration procedure and maintenance for the equipment? So these are really to extract the essential information that's needed when validating and monitoring a project. If we then move on to the calculation workspace, here you can see we've got the monitoring period, which is also always a standard set that we have. We've also got months because, again, we're collecting data on a monthly basis. When we look at the parameters here, you may note they're slightly different from the previous project that we looked at. And that's because there is a level of subjectivity in terms of how one does these calculations. In this methodology, what we've done is we've defined a grid emission factor as a constant value. So each project that uses this monitoring component methodology, they need to go and define what the grid emission factor is for that project. In the example project that we looked at previously, or that we built over the last couple of weeks, that used the baseline calculation to determine the grid emission factor. So you can see there is some flexibility or generalization in how one can go and build a component methodology. Again, we've got project emissions. In this case, again, we use a constant value. So we're saying because it's a PV project, it's likely that this value is going to be 0, so there'll be no project emissions. Here we are tracking the electricity that gets consumed from the project. And this is a parameter that's going to be measured. We also define the monitoring period start and end. Again, these two parameters are default parameters that are built into the system, but we do need to define the beginning of a monitoring period and the end of a monitoring period. The baseline emissions, this is something that's calculated. We'll see how it's calculated in a moment, but it's going to be related to the grid emission factor and the amount of electricity generated by the project. And then we've got these two parameters here, which are used to store information about the aggregated baseline emissions for the monitoring period and the emissions reduction for the monitoring period. These are dependent then on calculations that involve the monthly information. So the emission reductions for the monitoring period is going to be the sum of the emission reductions per month in that monitoring period. And we do the same for the project emissions. If we look at the equations that we have, this is a calculation for the baseline emissions. And it's actually interesting to note, it is possible to include, or one needs to decide whether you include a calculation within a baseline methodology or within your monitoring methodology. For flexibility in terms of the reuse of a baseline component methodology, for example, it may be better to have that calculation in a separate component. For the purposes of this example, we've done that baseline emission calculation within the context of the monitoring methodology. The second equation is aggregating the baseline emissions in the month over the monitoring period. You will become familiar over time with the syntax used within these formulas. Essentially, the parts here within the curly brackets define the period over which the months are collected. So here we're getting all the months in the monitoring period, and then we're summing up the baseline emissions for all those months. The total project emissions for the monitoring period. This is interesting in this case because what we've done, we've assumed that there are no emissions in the monitoring period because the PV project doesn't produce any emissions. It could be that one could develop a component methodology where you can have, let's say, a backup generator if you're obliged to provide energy. And in that case, there would need to be a calculation procedure to calculate your project emissions based on the consumption of diesel. Then the emission reductions, similar to the calculation we did in the other monitoring component methodology. It's the electricity consumed from the project times the grid emission factor. The 1,000 is to do a unit conversion, and then the minus the project emissions. In this case, the project emissions will be 0. And then this is aggregating the emission reductions for the monitoring period. I'm just going to go back to the project summary. Okay, and what we did now is we just reviewed that. We can now look, so that was really looking at the component methodology and how it was set up. From within our example project now, we can go and view the data that you used for the example project to go and test the component methodology that we've developed. Within that, we start off again with the sets. They're the 2 sets that we've defined. They're the monitoring periods, and then they're the months. In our monitoring period, what we've done is we've defined these 2 monitoring periods here. We can go and view these. So the first monitoring period is from the 1st of March 21 until the end of December. And the second monitoring period is between June and September in 2022. Okay. In terms of the months that we have, you'll see the dates need to be represented as unique states. This is it's a simple calculation to do. It's really the number of seconds from January 1970 to the date that you're looking at. One can come here and edit the different values. So let's say you want to add or change a month, you can go and edit it. So those are the months within the example project that we've defined. The next step in the process is to capture parameter values. The parameter values are captured as defined by the dimension of that. So when I talk about the dimension is really the value or the number of sets used to define the parameters. So you can have multiple dimensions. In this case, we only have one, which is month. But we could, for example, define electricity consumption at 2 different sites. And then I would use months to define the period, and then maybe S for site to define the sites. One would have to provide the data for each or for all the combinations of those dimensions defined for a parameter. And again, here, what I want to do is just sort on type here, because then it helps me manage the process of capturing the data. The first one here is constant, which is the grid emission factor. I can go and view that. The details that are provided, okay, the name, the unit that it's given in. You'll see in the calculation that we do, we multiply in the calculation of the baseline emissions, we multiply it by 1,000 to get kilowatt hours. And that's because I think we can check just now, the consumption of electricity from that project is likely to be in kilowatt hours. So that's why we're doing the conversion. This is, we assume in this component methodology that the emission factor isn't, the grid emission factor isn't changing. So there is no monitoring frequency here, which we need to check the spanning. This then provides a description of the parameter, how we're going to use it, and where it comes from. With this particular parameter, because it's a constant, there aren't going to be any quality control procedures like a calibration. Okay, the second parameter we have are the project emissions. We said it's a constant, and I think what we do is we define this as having a value of 0. And again, we give the details related to that parameter. So here we've got a comment, which is related to the project emissions, and because there's no fuel used, we assume that there aren't any project emissions. Okay, the next parameter we have is the electricity that's being consumed by the project or from the project. In terms of this component methodology, we've defined this as a manual input, and we can then go and view the details for this parameter. Again, we define the unit. Here, this confirms what I said earlier, that the consumption's in kilowatt hours, whereas the emission factor we're using is in tons per megawatt hour. And that's why we do that, divide by 1,000 in the calculation of the baseline emissions. This data is collected monthly, and there's some more descriptive information about that. What's starting to become more relevant now is, okay, how do we measure this? Okay, there'll be some electricity meter. There may then be some quality control procedures, like it needs to be installed by a qualified person. It must be calibrated according to manufacturer specifications. And there needs to be logging of this information. This is the primary input parameter that's used in the calculations that we have. Okay, I just want to go back here first. And so we're looking at the electricity consumed parameter. What we did is we looked at the parameter details, which gave some descriptions there. When we viewed that, it actually went to the same page that has the data, but it zoomed just to the point that had the details. We could get to the same data by clicking on view data. And then we can see what values were captured for each month within our monitoring period. It is possible from here to go and update a value or to delete a value. One can also go and see a history of how you may have changed the value in the past. This is more for a auditing function, not from a verification perspective, but from a data management perspective. We also do provide a graph here to show how the consumption has changed over time. Within the instruments that we use, it is possible to define calibration procedures for them. One should, for the parameters that are being measured. And then we would add calibration events for each calibration. We haven't included it in this monitoring methodology, but I'll show that in the next level of complexity for this project. Okay, and then the next two parameters here are just to define the start and the end of the monitoring period. And that we've looked at before, so I'm not going to go into the details. In terms of the equations, these ones here look, well, I want to say tongue-in-cheek, straightforward. So the first equation is really doing the baseline emission calculation, which is then the electricity consumed from the project times the emission factor. You'll see the units here. The electricity consumption is in kilowatt hours. The emission factor there is in tons per megawatt hour. So the units here are going to be a little bit funny. But what happens when we do the emission reductions, we then adjust for that unit difference. Okay, so the baseline emissions are calculated there. This second equation is aggregating the baseline emissions from each month into the monitoring period. The project emissions are 0 because we defined PEE as being 0 because there's no emissions from the project. And then the emission reduction is the difference between your baseline emissions and your project emissions. Things could have been simplified here because we could have just put baseline emissions into this, but I think that 1,000 there should actually be included in this equation. Okay, and then the total emission reductions for the monitoring period is an aggregation of the emission reductions for each month in that monitoring period. Okay. In this table over here, this is showing the actual results of the model. What we would need to do to populate the results is to click on the calculate button. Okay. When you click on the calculate button, depending on the size of the problem and the volume of data, you may need to wait to be informed about the calculation. This one is quite a simple one, so the calculation is almost immediate. For those that are interested, this is the code that gets solved by the equation solver. The first things is just pulling data from the database. The main things or the main model is really here where we define the equations that get solved. The last bit here is really just inserting the values from the calculation in the database. So the main parts of the model are really these equations here, and then the definition of the sets and the parameters. It is then possible to view logs. The logs are related to whenever you run the model, and it can be useful looking at those to see how you resolve the problem. So you can see when we first started running the model, we were having challenges with some errors coming up, and then through trial and error, we were able to solve those. We can then also go and view the results from here. There are other places that we can go view the results. You'll actually see this has taken us back to the previous page we were on. But those results then are all presented over here. The results that we're interested in are really just the output variables that get calculated. We already have the input parameters because that's what we put in. So the baseline emissions, we can go and view the, sorry, that's the details. We can go and view the results for the baseline emissions, and this is what's being calculated. You'll see the electricity consumption that we had was the same for each month, but that's why the baseline emissions are the same for each month. It is possible to download the data from results. This will then download it into a comma separated data file. And then something that's on a different page. We can then go and view the data. Okay, there is no data. I'll have to check on what's happening. If we look at some of the other output variables, the main one that we would be interested in is, of course, the emission reductions. So over here, we want to see the emission reductions for the monitoring period. This is what would be issued if the emission reductions have been verified and the auditors are happy and the Environmental Integrity Committee is happy. So we can then go and view those results for the emission reduction. Okay, and then here we can see for each of the monitoring periods what the emission reductions were. I don't think we gave data for the second monitoring period, so that's why it's 0. Okay, we can then go and view for each of the months as well. That's what's aggregated in the one above. And then the project emissions will be 0. All of those. Okay, so what we've done is we've shown you two. This is looking at another window. We've shown you two methodologies that are for roughly the same type of project, which is PV emission reductions from a PV project. Okay, so this is the example project that we've been developing to show the baseline and the additionality. if we view the project, it's made up of these component methodologies. This is the monitoring and evaluation component methodology. I like to access the methodology through this means. And then we define the parameters in the equations for this project like this. And then for this other component methodology, we see there's some slight differences. The main difference being where the baseline emissions are being calculated. So this component methodology that we developed in the previous example used the baseline component methodology for the baseline emissions. In the second monitoring component methodology for PV project, what we did is we built the baseline emission calculation into the monitoring component methodology. Okay. Now, additional complexity. So for the credibility of the credits, there needs to be a robust verification and ensuring the integrity of the data. Quite a large part of that is to make sure that instruments are accurate and also calibrated as they should be. The monitoring methodology should define the calibrations procedures for the specific instrument that you're looking at. And then this is done because things can go wrong. You can find that an instrument can drift over time, which is why some instruments you calibrate on a regular frequency, like once a week or once a month. It is possible that you could miss certain calibrations that you should do. And for that, the standards define these calibration procedures and how to do a delayed calibration. What the delayed calibration does is it's a means to adjust the value that was measured while you were outside of a valid calibration. So in the next example that we look at, I'll show one of the ways that one can do that. For that, we've defined some terms. These are purely in the definition of the component methodology that we developed. So you could use other terms within that. Although I think this is a useful guideline for that. So what we have is a measured parameter, and the lines are then showing the value that's measured, which will be the black line. And then the vertical lines are the calibration events that should occur. So this could be once a month that you need to calibrate your gas analyzer, or adjust the calibration on a flow meter. Then what we've done is defined instrument accuracy, which is really about the specification of the instrument you're using. And then there's a calibration tolerance, which is what's being deemed acceptable in the approval of the methodology for how much your calibration can be out from the instrument accuracy. And then when one does a calibration, you would then bring the value back to the true value. So for example, here we've done a calibration, and we see that this blue dot here is the real value that's measured during calibration, but the reading was actually where the black line is. So you could define and say, okay, well, if your reading was within your tolerance, that's fine. We can see over here we've done a calibration, and the real value is quite far from what the instrument was reading. And what that would require, that will be fixed during the calibration. But what I'm trying to highlight is that over here, when we missed a calibration, there needs to be an adjustment of this value, which was measured, to that value there based on the error at the next calibration. So the purpose of the delayed calibration is to adjust historical values that were measured outside of the calibration period by the error measured in the next valid calibration. So I know that's quite a mouthful, but I'll try and explain how that's been implemented within a methodology. Can I pause there for any questions? Are there any questions?
No questions in the chat so far.
Okay. Okay, so what I'm going to do here is I'm going to then go to another project where I have a delayed calibration. Okay. This is actually a trial project that we've been working on. Benoni Snacks is in Kempton, and they've got a PV installation on their distribution center roof. And we've been actually logging information for the last, it's been more than a year from their project, and we've been calculating the emission reductions. Okay. Here we can see the different component methodologies. What we want to see is the monitoring and evaluation of that project. Oh, I don't have a calibration. Sorry guys, I just want to check which projects I want to look at. So Serena, are you online?
Yes, I'm also trying to look for the relevant project that needs calibration. So give me 1 second.
Was it the R project?
So the landfill gas destruction project on the Dev app does have some calibration events that are due. If you want to look at that, it's project number 42. And I see project 65 seems like it also has a calibration due.
Okay, cool. Thanks. This is a project here which we built calibrations into. What a calibration requires is your instruments in the quality control procedure. One should define the frequency at which your instruments are calibrated. What we've then provided for that is, in this particular methodology that we're looking at, is you can then define calibration events. And a calibration event logs the data at which calibration happens. It logs when the next calibration should happen, and then information about the instrument. And one can then also upload the calibration certificate for that. And what will happen when one is doing a verification is that the auditor would want to see the calibration certificates for the different instruments that you have. And what they would then check is, have all the calibrations been done when they should have been done at the required calibration interval. They will also then check if there's a missing calibration, has there been an appropriate adjustment to the measurements that you've taken based on the next valid calibration. And if the instrument has drifted out of calibration, then an error adjustment must be applied to that calibration that was missed, or to the measurement for the calibration that was missed. Okay. So then, related to the calibration events, one then needs a set of parameters to manage the calculations related to that. Okay, so this is looking at a component methodology, which includes calibrations. That's defining sets. In this project, we are actually collecting information on a minute-by-minute basis, and it gets aggregated to hours. Within the sets that we define, we have this parameter, or this set called calibration parameter. And this then is used to contain the names of all the parameters that need calibration. And then the other set is the calibration event, which then contains the sequence of events for calibration. When it comes to using that calibration, what we have is a parameter that has an adjustment based on the calibration output. So we may have exhaust temperature somewhere here. Or there should be temperature somewhere. Okay, so here we've got an exhaust temperature that's being measured. And over here we've got an adjusted exhaust temperature that then adjusts the measured value based on any calibrations that may be out or missed. If we look at the calculation procedure, you'll see we've got one for adjusted flow rate. We were looking at the exhaust temperature. And there's this big complicated equation, which I don't want to go through in detail, but I want to try and explain what it's doing. I'm going to copy this. I'm going to put it in here, and what I'm going to do is break this up so that it's readable. if that's possible. Okay, so what we see here is there are two bits. This one here is just defining the parameter that we're looking at. This over here is assigning a value to it. And let's focus on this last bit because that's where the calculation's happening. And what we're saying is that if we are out of calibration, we should then adjust the measured value by some other value. Now, what's happening is the methodologies themselves define what the adjustment should be. Some of the existing methodologies for other standards, what they'll do is they'll say, if your calibration is out, you should adjust by the calibration tolerance. There are other ways you can do it. You can say if your calibration is out, you should adjust by the error measured in the next valid calibration. This here is saying if your calibration date is outside of your calibration interval, then I should multiply my measured value by 1 plus the tolerance. This tolerance is a percentage. If it isn't, then it's just going to multiply that value by 1. So that's the adjustment that's being made, which is relatively straightforward. The question is what's happening within this thing over here. What is happening over here is that we define the calibration events, and what we're checking to see is this may help. We are defining calibration events, and there could be measurements that are happening in between here, and when we don't have a calibration like this over here, we check and see what's the difference between, there may be many data points along this black line, and we are finding the difference between the value along here and the previous calibration event. So you'll find that when we get the difference between this point in time here and that point in time there, that we're outside of the calibration interval, which would mean that all these values over here would then have to be adjusted by the error that's being measured over there. That is what's happening over here, is it's looking to see what are the different, in this case, we're looking at an hour. What are the different hours over here that are outside this calibration interval? But I think it's difficult to explain this in our open forum. I think what guys should try and do is try and figure out what's happening there. And then we can have more detailed discussions offline or via email to see if any assistance can be provided. Okay. Are there, there probably are, but are there any questions related to that?
I don't see any in the chat so far.
Okay. Let's see what else we have. So what we've done now is we've gone through the process of defining a component methodology, how one sets the different questions for the component methodology, which would then solicit the information from the project owner that's using that methodology. We then also define the parameters that should be measured for the monitoring of that project. Whether those parameters need to be, whether they have some quality criteria or calibration requirements. And then what we've done is we've taken the different component methodologies that we have designed, and we've put them into a example project. Then with the example project, we're able to populate all the parameters for the component methodologies in that project and run the project to see what the emission reduction calculations are. After that whole process, there are a series of different documents that we can then go and view on the platform, which summarize either the component methodologies or the monitoring data or the monitoring report from the example project. These are useful ways of just looking at the project from a different perspective. Although all the information is available on the platform. So let's go and have a look at some of those documents that are available. If we start here and we go back to our example project that we've been working on all the time. Okay, and let's say we go to our monitoring and evaluation component methodology. We can then sorry, Serena, I've drawn a blank. I want to see the report that summarizes the.
So normally I will go to are you in the, if you go onto the project itself, then yes, so you can do view documents. Yes, that should take you to a page that has everything there.
Okay, so this is showing the reports for the actual example project. So one can go and view monitoring report. If you click on it, it generates a PDF document. And then in the PDF document, it'll then provide everything that's being provided for that project. So the details of the person, project description, and whether there are any additional information that's needed. There's also the data report, and this then contains a summary of the data related to that project. It's got the same order and structure as what's on the platform. Here it defines the different parameters, it gives the descriptions. This looks very much like the monitoring reports from other standards. And then as we go further down, we will then get the information related to the equations. So you can view them all here. And then we can view data that's being provided within the project. Now, what's quite important is that we don't want to create a 1,000-page document because it's got minute data from our flow meter. And that's where it's important that when you define your parameters, whether you say the parameters should be available within the monitoring report. So this, our recommendation is you should only include the aggregated parameters like month values or monitoring period values. So this report is then providing all the summary of the calculations and the results of the emission reduction calculation. What I wanted to find was there is a specific report. Robert, are you in the call?
Just say again, Philip, what you're looking for?
It's possible to get a report on the methodology. It just summarizes the methodology. Essentially, it defines all the parameters and the
Yeah, so if you navigate through your project at the start there, just to find the methodology.
I think it's this here.
Yeah.
Okay, so what I've done is I've gone to methodologies. This methodology is the monitoring methodology that we developed for the example project that we've been working on. And here you can go and download this PDF. And this then provides a summary of that. So you'll see things like what are the scopes of the methodology, what is it compatible with, and then it'll show things like the definition of the input fields, the parameters, and the metadata related to those parameters, and then the equations. So what I'm trying to show you here is that there are a series of different documents. You may or may not need them depending on how you operate. But if you want to provide a summary to someone that doesn't have access to the system, you can generate a report that summarizes methodologies and reports that summarize different bits of a project. So that there's the monitoring report. Cool. Okay, so what is the next step? You've gone through the process of defining component methodologies. You've then used your component methodologies in an example project. You then test those methodologies by solving for that example project, and you find your project is, or your methodologies are ready, and what's the next step in that process. So let's say the next step is that you want your component methodology to be approved so that you can use it for a real project. So I'm here by the component methodologies proposals, and I can then go review and submit. So this then summarizes the component methodology in very much the same way as the PDF report does. And you can then go and view the questions that you have in there for the template. You can view your sets, your parameters, and your equations, and so on. Then when you're ready, you can say, okay, I'm going to submit this for an audit. Okay, I want to create an audit. Okay, then the question is, who's going to audit the project? I'm not sure if we have a list of auditors yet, but one would then go and select an auditor. Okay, we have an example auditor. Cool. We'll go back. I can then say what I want them to audit. It's selected this one by default. For the auditors to be able to audit a methodology, they do need an example project. And this is so that they can check that all the calculations are being done appropriately. I can then go and select my auditor, and I can go appoint and submit. Okay. Usually, one may negotiate with the auditor before you appoint them. In other words, you would, outside of the system, go and ask for a quotation. You may then review the submissions by different auditors. Once you've done that, you can then come to the platform and appoint that auditor. Okay, and now I've submitted this to be audited. Either Robert or Olivia will receive it because this is a demonstration system. This was, then you'll see that the status for this has changed. It was on C100, which was under development, but here it's being submitted. When you submit your component methodology, it does become available then for public comment. And again, you'll see there are component methodologies which we've put onto the live system. And if you would like to go and have a look at those, we welcome any comments on those component methodologies. Okay. So at this point, you then need to sit back and wait and get some sort of a response from the auditing process. I think I'm mostly done then for today, but perhaps we can ask before if there are any questions or any inputs or comments. That'll be great. Any questions from the Promethean team?
Maybe I'm going to answer your question with another question to hear from the audience if there's maybe something that they would like us to expand upon or provide more information on. Perhaps we can even do that offline, but there are maybe certain areas that you want more guidance, information, or just details on. It'd just be good to be aware of that.
Okay, cool. I
I've
think
got
also, yes.
Sorry, I've got a question. So we've been working on a biochar methodology for like over a year now. And we're in a process with some peer experts in the US. So I was just wondering, you know what I mean, is it possible to make reference to, and how can I say that, a methodology that's fully written up in PDF format? I'm just thinking about how comprehensive the information on the platform needs to be. You know what I mean? Because most of our sections, for instance, has been written up. So is it a kind of copy and pasting it into here, or is it a bit more of a light version and making reference to a methodology?
So the idea with the ICS is that it expedites the process for doing the calculation, and it facilitates the collection of the data. So the first thing in the process would be to capture the methodology, and the calculation procedure. That methodology would then need to be approved by the Environmental Integrity Committee before it can be used in a project. Then once that, actually a part of that process, you could capture the data for your project that uses that methodology as an example project. And then you can submit the methodology for approval. And then once it gets approved, you can convert your example project into a real project. And then continue collecting data within the platform. So there would be 2 steps in that process. Converting the methodology onto the ICS, and then capturing the data related to the project that uses that methodology into the ICS. Does that answer your question?
Yes, yeah. I think it's just the only thing, maybe it's just the comprehensiveness. So is the idea of having the full methodology on the platform, so all the sections written up in there. I'm just not sure how much space there is kind of on the text boxes, for instance, that you actually put in your data or in your text.
Yes, so you can put quite a lot of text in there, and I would be just as comprehensive on the ICS as you would be in any other standard. Okay. The idea, though, is that it automates the calculation procedure. Yes. So once you've proved the calculation works, you don't have to redo that process in terms of providing a monitoring report or anything, because it would be generated by the system.
Perfect. Thank you.
Cool. Okay, I think then if there aren't any other questions, we'll call that a day. Simone, is there anything from your side?
Nothing from my side. Thanks, Philip.
Great. Thanks, everyone.
Thank you, Philip. Thank you, Simone.
Thanks, Philip. Bye, everyone.
Thanks everyone.
Thanks. Bye.
Bye.
Thank you, everybody. Goodbye.